Hello everybody, let's talk about today more on slopes, and this is objective 1.5, and please watch all the videos for pre-calculus in order so it will make more sense to you. Today we are talking about slopes. We are talking about how to find slopes, and equations of, and we're gonna look for equations of parallel and perpendicular lines. Parallel, I'm just going to draw these two lines for parallel lines, and perpendicular lines, we do this, that's a sign for perpendicular lines. And we are also going, for example, let's talk about equations of the parallel and perpendicular lines. So what are parallel lines? Parallel lines will always going to be when their slopes are exactly the same. For parallel lines, the slopes are the same. Slopes are same. So for this, parallel lines, the slopes are always the same. If I have two parallel lines, their slopes, if one line is half, the other one is still half. If one line is 3/2, the other one has to be 3/2. Then the lines are parallel. Now, perpendicular lines. What are perpendicular lines? Perpendicular lines, I have two different ways to find out if the lines are perpendicular or not. First, slopes are reciprocal, and opposite sign, and opposite signs, or the product of slopes is equal -1. Then the lines are perpendicular. Okay. Now, what is reciprocal? Reciprocal, when you have 3/2, the other slope is -2/3. So it's a reciprocal and opposite sign. Okay. In the product of the slopes, that's another way you can use each one of them. Either one of them, whichever makes sense more. Now, let's talk about what is rate of change. Rate of change. Rate of change means slope. Okay. Rate of change means slope. So what kind of slope? So it means when we measure rate of change, then at a specific instant in time, when we measure rate of change at a specific, I'm just going to write a few words here, at a specific instant in time. Now this is called rate of change. It describes how fast y is changing with respect to x. And we usually use a formula for this, which is change in y over change in x. So how fast y is changing with respect to x, or we can use a formula that we are really familiar with, y2 minus y1 over x2 minus x1. Both of them are for slopes. Okay, so this is one formula for rate of change that we use. And what kind of rate of change is this? At a specific instant in time. And most of the time we use this for linear functions. Okay, now we have another one which is called average rate of change. Average rate of change. Average rate of change is also a slope, but this one tells you the average rate of change at which something was changing over a longer period of time. Something changing at longer period of time, So this is average rate of change. And what is the formula for this is going to be? It's going to be average, let me use a red one. It's going to be average rate of change equal f of b minus f of a. What is a, b? These are real numbers. These are x values. And b minus a. You can use f of x2 minus f of x1. You can use that, or I mean, whichever makes sense to you. x2 minus f of x1 over x2 minus x1. I just use b and a instead of 1 and 2. So this is the formula for the average rate of change. Now let me give you a graph for this. For example, rate of change, like I said, it's a specific instant in time, right? Linear function. What is linear function? It's going to go something like this, right? For example, I have a graph. So you pick 2 points on this graph, and then you're going to rise or run because it's a positive slope, or you use these 2 order pairs up here. You can say that's x1, y1, and this one is x2 and y2. You pick these 2 order pairs, plug it in the equation, and you will get rate of change. Now, what about this one? Average rate of change. Now, average rate of change, I never said it's for linear function, okay? It's going to be something like this. If you have a graph, and the graph is going like that, find the average rate of change of this. So you're going to draw, for example, a line like this. The line that is touching the graph twice, like in 2 places, this line, when touches the graph twice, is called a secant line. Okay, now you pick these 2 points, you plug them in here. For example, this one is b and f of b, right? This is x, that's a y, and that one is a and f of a. Okay, these are 2 order pairs. For this one, you plug them in and you will get the answer. Now, average rate of change is also called secant slope. Secant slope. You know, because we get this from the secant line, that line that touches the graph twice, that's a secant slope or a secant line. Okay, so that's all about the average rate of change and rate of change. Okay, rate of change is at a specific instant. This one is over a longer period of time. Let's do these equations, these questions right there. The question is, write an equation of the line passing through -2, 5 and parallel, okay, to the line whose equation is y equal 3x plus 1. Express the equation in a point slope. Okay, so if you guys pay attention and remember, word problems, the way I solve, I just start what they're asking me and I go step by step, I go backward. Okay, so when they said express the equation in a point slope, you know point slope means this: y minus y1 equal mx minus x1. Okay, I got my point slope. Now, you know that for point slope, I need a y1, okay? I need m question mark, and I need this x1 question mark. So this is all the things that I need, and I'm going to replace y1, m, and x1 with some real numbers. So how do we get all that stuff? Let's figure it out, okay? Now, this one, the one they are giving me the question, they said this is -2 and 5. So I already know this is x value, that's a y value. And since they use the word parallel, and parallel, like the new equation, the new line that I'm talking about, like this one, is this line is parallel to the equation y equal 3x plus 1. So what does parallel means? When the slopes are the same. So if this is my slope, you know this is y equal mx plus b. This is m, which means that's a slope. So the slopes are the same, x and y are already given. All I have to do, replace this and plug them in, and you are good to go. So let's do it. Y minus, what is y1? It's 5. What is slope? It's 3, because you know lines are parallel. What is x1? That's -2. Do you see that? -2. I can simplify these negative, and other than that, I'm not doing anything with it because they are already telling me express equation in a point slope. So this is my equation in point slope, and we are good. Okay. Let's try another question, which is right there. I'm gonna move this upward right there. Let's do this. Now this question is asking, find the slope of any line that is perpendicular to the line whose equation is this. Okay, so find the slope. Okay, look at this. I start what they're asking me, okay? I'm starting where they are, what they're asking me. Find the slope. Slope means I'm looking for m. Of any line that is perpendicular. Perpendicular, if you guys remember, reciprocal and opposite signs, or the product is multiplying, the two slopes multiplying, the two slopes of the lines are multiplying, and we are getting -1. Then it means the lines are perpendicular. Okay, to the line whose equation is this. Now, if you check this equation, how can I tell my slope is what? You cannot tell. Please don't make that mistake that you say every time the slope comes with x. No, because x has a 1 right there. So I'm not going to say my slope is 1. You have to change this equation into y equal mx plus b. If you don't change this into this form, don't tell me the slope is 1 or 3 or 12 or 0. I don't know anything unless I change it. So let's change x plus 3y minus 12 equals 0. I have to change this into y equal mx plus b, and then we deal with it, okay? So y, do you see the y is on the left side of equal, and it's positive, and it's all by itself. So this is my equal sign, and I can tell y is already on the left side, but the problem is it's not by itself. So what I'm going to do, I'm going to keep this y in the box. I'm not touching it, and the rest of the stuff I have to move to the other side of equal. So let's move x first. Subtract x, subtract x. So this is cancel. What am I getting? 3y minus 12 equal -x. Okay. Now again, I'm going to box my y. I'm not touching that. Let's move the 12. Remember, any number with the variable that I am supposed to move, don't touch that. This is the last thing you should do. So I have a plus 12. Cancel, cancel. Since they are not like terms, so of course I'm going to keep it. Now I have 3y equal -x plus 12. Now what do I do with this 3? Get rid of it. How? They have a multiplication between them. We use opposite operation, which is a division, and I'm dividing everywhere. Okay, cancel, cancel. Got y equal, you know this is invisible 1, so I got -1/3 x plus 4 when I simplify this. Okay, so this is my equation right now that I changed it into y equal mx plus b, and I can tell my slope is -1/3. Now, since they are asking find only the slope of the perpendicular line, so what is the slope? I'm going to use this slope. And how do I change that slope to the perpendicular line slope? Again, reciprocal and opposite sign. So look at this, 1/3. So reciprocal is going to be 3/1. And negative sign is going to turn to positive because that's what it was, reciprocal and opposite sign. And this means that's the slope of the perpendicular lines. Okay, so the slope is going to be the slope of the perpendicular line, slope of perpendicular line is equal 3. That's what it is. You can put 3/1, doesn't matter. Okay, let's try another question as a rate of change. So the rate of change is something right there. In 1990, 9 million adult men in the United States lived alone. So my information is right there. I'm just going to circle it. In 2008, 14.7 million adult men in the United States lived alone. Use this information to find the slope of linear function representing adult men living alone in the United States. Express the slope corrected 2 decimal places and describe what it represents. So everything that I underlined it, this is what I'm looking for in each one of them, okay? So since they said find the slope, so I know the slope of the linear function is m equal y2 minus y1 over x2 minus x1. That's my formula for the slope, you know that. So where do I get my x1 and y1 and y2 and x2 and all that stuff? So do you see this? That's your x1 and y1 and x2 and y2. So let's put them in order. So I'm gonna put, I have two order pairs. For example, I have 1990 and 9. I'm not writing million with it or zeros and stuff. I'm just gonna leave it here. My answer is gonna be anyway in million. So that's my one order pair. That's my x and that's my y. I can say that's x1 and y1. Right? Then I have another order pair which is 2008 and 14.7. So that's my x2 and that's my y2. So let's plug in it. M equal, what is y2? 14.7 minus, what is y1? That's 9. X2 is 2008. X1 is 1990. Okay, when you subtract these two, I'm gonna get 5.7. Use a calculator and subtract. When I subtract these two, I'm gonna get 18. When I divide, I'm gonna get approximately 0.32. And since they said 2 decimal places, then I do have a 2 decimal places. 2 decimal places means how many digits you have after the decimal. So when they said 2, then it's 2 decimal places. So, and then I answered each and everything if you guys pay attention. Slope of linear function, 2 decimal places. Now they said describe what it represents. So what is this? This means the rate of change is 0.32 million men per year. Okay, that's the interpretation of that 0.32. Okay, so we got that. Now let's go back to the other question. I have another question right here that I'm going to write it down. That question is, find the average rate of change. Okay, that's another example. I'm just going to write it down myself, then we will go back to this one. Find the average rate of change. Average rate of change. Rate of change. Okay, and if you guys remember the average rate of change formula, average rate of change formula was f of b minus f of a over b minus a. I'm not using x2, y2. I mean, you want to use it, go ahead, but I'm not. The function they are giving me, find the rate of change for f of x equal x cube from a equal -2 to b equals 0. Okay, so now, and sometimes they give you this is x1 and that's x2. Like I said, you can do it however you want it. So I'm going to figure it out first, the y values. You know, these are y2 minus y1, right? F of x2 minus f of x1. So I'm going to plug in this function these two a and b's. Once I find out that, then we will be okay. Let's see. What is b? B is 0, so find out f of 0. What is a? A is -2, so find out f of -2. Over, what is b? 0 minus, what is a? -2 parentheses. Okay, so let's plug in 0 for in the function. If I plug in 0, you know I'm going to get 0. If I plug in -2 there, I'm going to get 8, right? -8. 2 times 2 times 2 times 8. And then this one is going to turn +2. This one is also going to turn +8 over 2, which will give me 4. So my answer is for this average rate of change for the function x cube is right there 4. Okay. Now next question is talking about velocity. Okay. The distance st in feet traveled by a ball rolling down a ramp is given by the function st equal 4t squared, where t is the time in seconds after the ball is released. Find the ball's average velocity. Okay, what is average velocity? Average velocity is the same as average rate of change. Velocity is the speed with the direction, and rate of change is also a rate, speed. So average velocity means average rate of change. Okay, and we're going to use the same formula that we use for average rate of change, and the formula was, if you guys remember that, since they're using the function st, so instead of like we had f of b, instead of f of b, f of a, I'm using st1 and st2 because that's what they are giving me right there. So the original formula that we have, average rate of change, I'm going to write that formula first and then we go change it, is going to be f of b minus f of a and b minus a. Okay, b and a, this is x2 and that's x1. Okay, so let's change it like for the st. How do we do that? It's gonna be something average velocity, and I'm going to change the formula according to that one. Okay, according to st. So instead of f, I'm using s. Instead of b, I'm using t2 minus s t1 over t2 minus t1. You see that? So it's not that hard. Okay, whatever function they give you, please make sure that you change it. That's the generic average rate of change formula. So let's figure it out. S2 T2, that means S2, and T1 is actually 1 over 2 minus 1. So it's going to give me, what is S2? Plug in 2 for T in here. So when I plug in 2, it's going to give me 4 times 2 squared, so 4 and 4, 16. It's going to give me 16, right? Or maybe you can say something like that. I can show you 4, 2 squared I plugged in. And then I have 4 and 1 squared. And again, this is going to turn 1. Let's go. That's 16, and that's 1 over 1. 16 subtract 4 is going to give me 12. And that's it. We don't have to write that 1 down there. And what are the units? If you guys pay attention, feet, and they are in seconds. So feet per second. Okay. So the average velocity is between 1 and 2 seconds is 12 feet. Okay. Now, I think that's the last question. Yes. So if you guys have any questions, please comment below and I will try my best to answer it. And good luck with it. Bye.